Check. Check, check. Check. Checking on the mic. Mm-hmm. Okie dokie. Could leave it up just to see. Check, check. Okay. Let's see. So let's start with this. I'll show you. I cleaned up a lot of the GUI stuff. If you remember, the background was like a horrible color. Everything was kind of weirdly sized and there were no styles. I added some like basic stuff just to make it look cleaner. So I've got this look and feel that I've used across other projects. I've got this simple look and feel for these dials as well from other projects. So basically all the macro and all of the like input output knobs are this little simple style. And then gonna use this style for all the knobs and stuff. And we can change the way the fill comes in. So when it's positive or when it's negative, and then we can have like a continuous one as well. And we can change all these colors and stuff for each module. But yeah, I need to add the header component from other projects. But yeah, we've got the graphic EQ, we've got the parametric EQ. So let's start working on the, what are we going to do? The Pultec-style EQ. So basically, it's not like I have a Pultec, but we can just Google Pultec EQ datasheet PDF. Really? Is it this one? I think it is. Yeah, perfect. An old manual, and you can see it gives us the low filters, so like their frequencies, boost and attenuate, how many dB they boost, the high end, boost and attenuate. I mean, I can't really do anything with the input transformer or the output transformer. That's just the noise floor, distortion. Anything else in here? So there's 2 preamp tubes and 1 power tube. We can kind of do a little something with that. I don't really know how much a real Pultec distorts. Maybe I could find a video or something where it shows it, but we can definitely pull in a tube and class B amp into it to give it a little bit of harmonics and stuff. Cool. Shape control. More of the same stuff, I guess. This is really handy. It gives you a little graph that we can check and plug in Doctor. What else? Anything else useful in here? Talks about the bandwidth a little bit. Doesn't give us much specifics. Obviously not going to model a circuit. Okay. Cool. So we have that to look at. All right. So what do we do? To start, when we add a new module, we've got to do the processor and editor. So we got to copy over. Let's see here. Where are we at? I don't even remember. Oh yeah, comment. Yeah. All right, source DSP processors. So we can take these. So this will be We'll do this. Sure, we'll leave it like that. I'll just copy this right here. All right, so that's the process block one. Now we got to do the processor. Okay. All right, that's it for those files. Now we got to do the editor. Okie dokie, there's the editor's done. So that should show up the C line now. So we just got to go in and change all the names, which this is annoying, but I don't really see a better way to do this. All right, so we've got let's processor. Let's do process block first. Actually, let's go to the utils and add it here. So we'll add one called LV Pultec EQ. Cool. Take this one. That and that. Let's see, Pultec EQ. Yep. Okay. So take this. Actually, do it like this. Control G. That's gonna be Pultec EQ. Okay. Oh yeah, the editor includes and the processor includes. Where is that? Right here. Okay. Pultec processor.h. Then the editor. Pultec. Is that not called LV Pultec? Okay. I don't know why. Oh, that's weird. Oh yeah, editor. Okay. All right, is that good right here now? Well, hold up. Apparently not. Oh, great. Okay. Did it also? No, it was wrong. Let's see. Editor includes. Is that right now? Yeah, Pultec editor. And what did I do? What's wrong with this? Ambiguous symbol. How? I bet when I refactored the editor, I bet it did something. Unless it was something else. Like, what's up with this? Cannot resolve symbol. LV. Oh, yeah, because I just changed the file names. So let's go to process block. And let's go to here. Actually, no, we're not going to refactor because then it's going to... change the ones that are actually named that and are supposed to be. So we'll do LV Pultec EQ parameters. Looks good. In fact, it might be more accurate to just take that part. And do, yeah, LV Pultec. Okay. That ought to work. Now the processor, we'll do the same thing. Okay. Why didn't that, I'm not sure why that happened. LV Pultec EQ parameters. LV Pultec EQ parameters. Oh, what's up with this warning? Import multiple choices. That's odd. What? Bro, why? Why did this happen? Okay, LV Pultec EQ process block. All right, so we gotta. Bruh, I don't understand. Okay, there we go. So let's try that again. Let's just do it like this. LV Pultec. Let's see that I also mess it up here. Nope. I don't know what's wrong with this. Oh. Odd. Let's see, let's go to the editor now. Okay. Did that fix this? Yeah, it did. I don't see the error anymore. Yeah, it's good. Okay. And then utils, is this working? Yeah, it looks like it. Okay, does that mean it's gonna build? EQ Pultec. All right. Let's make sure that saves and opens up. Yep. Okay, cool. So we're gonna need some parameters, and we're gonna need to make a quick GUI to get this working. So let's go into the process block, and we need our parameters. Okay, so we need our boost of 10, bandwidth, 2 frequency selectors. Then I guess that's a low pass. Is it? Does it say? 5, 10, 20, shelf attenuate. Okay, it's a shelf, but yeah, okay. So we're gonna have 1, 2, 3, 4, 5 filters. Is that the light? No, this is the light. So what's this? What is this? Oh, it is the power switch. It's, yeah, okay. So the power switch is right here, and the power LED that shows you. Well, no, that says off, doesn't it? Also, this is just a plugin. Let's see. Well, no, it says off, on. Okay, and then it says in. In is usually just an off, on, right? This one has a tube. Actually, yeah, let's just do that. We'll have our on, off, and then we can also have a tube button. Yeah, let's do that. Okay. It's not like this needs to be a 1-to-1. It's just another EQ flavor. Okay. So we'll be decide on 5 filters. Yes, and then 2 bandwidth, 3 bandwidth filters. Well, no, sorry. 5 filters, 3 dials just for frequency and bandwidth. Okay. So all right, let's it's not really a lot of parameters, so I'm not going to really worry about trying to automate it, or not automate it, but make it shorter. All right, so we'll get rid of all these. Rid of that. Yeah, okay, let's do this. Okay. Okay. Low boost. I'm an idiot. I should have. Okay. Low 10. We got anybody in the chat? Just check real quick. Okay, there's 2. All right, so there's the low 10. All right, so we're gonna have high boost and high 10. Cool. High boost, high 10. Okay, okay. Looking good. Then we've got what? Low and high frequency cutoff. So low, high. So let's do low, I'll just do freak. And then one more, right? Just the bandwidth. Oh, plus the tube button. I guess we'll also do a power button. Okie dokie. Not too bad. Okay. So we don't have a drive, so we can take that. Let's just move it over here. So we got low boost, high boost, low 10, high 10, the two frequencies, the bandwidth, and the two power buttons. Okay. So this is gonna be, that's not the best way to do it. Let's just do it like this. Low boost, low 10, high boost, high 10, low. Oh, I just realized I missed one. High freak, and then bandwidth, and then we've got tube and power button. We need the it's called the attenuation select, probably, right? Again, it's just for the high end. Okay. High attend select. So like this. Oops. Yeah, just like that. Okay, and then we gotta go add it here. High attend select. And let's get rid of these. Actually, we are gonna have, let's leave this because we're gonna use some enums. The only thing is, let's get rid of all of this, I guess. We're probably not gonna need drive. So get rid of that. Oh, wait, let me leave. Oh, no, sorry. We're good. Let's get rid of all of this. Let's see, no drive smoother, no filters, none of that either. Okay. Right. All right. So now let's set up these things. Okay. So let's just do the first one, and it's going to be a float. And this is going to be low boost. Like that. Okay. So low boost, high boost. Low a 10. Then low boost, high boost, low 10, high a 10. Then the high a 10 select. Okay, and then the two frequencies. Low, yeah. That works, yeah, okay. And then lastly, the bandwidth. Okay, and then we got two buttons. So let's copy the mute over here. Yeah. Tube and power. And these are supposed to be bools. Okay, that should work. All right, I think that's everything. I think actually the low freak and high freak and the high 10 are going to be ints, but we can deal with that in a minute. All right. Yep, get rid of all this, maybe except for one of them. Yeah, so get rid of that. Get rid of this. Okay, that's it. Okay, low boost name. And what is our range? We don't need a range variable for the gain boost, but what did they go to? Up to 13.5. Okay. So yeah. 13.5 is weird, but I don't know. It seems more scientific. All right, and then the low attenuate is 0 to 17.5. All right, now the high boost and high attend. Okie dokie. The high is to 18. High boost. And then the high 10 to 16. Okay, and then the select. What is it? 5, 10, and 20. Why doesn't it say it in the data sheet anywhere? Okay, well, it doesn't matter. We know it's that is 5, 10, and 20, right? I think so. Let's see. So this can be kind of annoying. Because with the integer parameter, if we go back and change one of them, let's go here and let's change the high attend select to int. High attend select to int. What we would do is this. So let's do this. If we were to, well, let's fix this as well. Integer. If, oh, this is high. Oh. So this is supposed to be 5,000, right? And then it goes to 20. The default value 5. But then you give it the interval value. And you can only do like, or am I wrong? Like if I put, I don't know, 5,000 for the interval value, you would start at 5 and it would go to 10 and then it would only go to 15. So I think I would have to it might be easier just to handle it in the dial. Well, no. Let's see what ChatGPT suggests to do right here. Oh wait, what? Now what? No viable constructor. Oh, maybe it doesn't take in an interval. In fact, we can see what int takes in. Min max default, okay, or min max default label function. Yeah. Okay. Okay, so this is gonna continuously give 5,000 to 20,000, but we want it to kind of snap. Okay. real hip hop. I do my best. I want this param to be only either 5,000, 10,000, or 20,000. So 3 snapped positions. Oh, it wants to do a choice, but I don't. Well, no, that's not going to work because I can't do a choice attachment to a slider. Then when you need the hertz value. Yeah, I guess this makes the most sense. And then what I would have to do is when saving and recalling, you would have to, after you do the attachment, get the value of the attachment and then apply it based on those settings. Well, no, still. Oh yeah, I guess I could just do, what does it want? It wants an integer. Okay. So we could do just 0 to 2, default to 0, and then just handle it. Yeah, okay, we'll do that. All right, so the other ones, let's see. Okay. Okay, 20, 30, 60, and 100. Okay, so 4. Well, that's for that. Okay, and then this one's, yeah, 3 to 16. Okay. All right, so what we would need to do is go to the process block, change those into integers as well. So that's the low freak and high freak. Yes. Okay. So high freak. Okay. And they will get let's put some space right here so I don't get lost visually. We'll change that to int. Yep. Okay. So the low freak is 0 to 3. And then 0, 1, 2, 3, 4, 5, 6. And that's it, right? So we got low boost, low 10. High boost, high 10. Low freak, high freak. That, and then we need a bandwidth, which will be a continuous. Does it actually say what the bandwidth is? Oh, wait. They are continuous. The wide range. Continuously variable controls prevent changing the amount of. Okay, yeah, okay, so never mind. I'm an idiot. Okay. So that's the. Alright. Take everything that says audio parameter int. And go back to float, and then we'll do the same thing here. Okay. And then, so the high 10 already said is from 5 to 20. $20 to 100. $3,016. I don't think it tells us what the bandwidth is. It just says from sharp to broad. So let's do maybe 0.01, and we're gonna use the juice IIR filter. I don't remember if it's the one that goes above 1 or not. I'm just gonna do 0.95, and then we'll have it at, like, I don't know, 0.7 is a classic one, or 0.707. Okay, we have any errors? We don't have drive anymore. I don't think we need parameter listeners. I don't know. We'll see. Let's make sure that doesn't crash when we build it. Uh-oh. Oh, okay, yeah. So let's just delete everything in here. Oh, we don't actually need that whole thing right there. We don't need that either. Well, that's gonna kind of mess us up. What's the best way to do this without ruining everything around it? Ooh, where are we? Oh, well, I guess we could just comment it out, but I mean, the resize method counts on these being valid. So there's this. Actually, this might be all right. Okay, yeah, that's fine. What's the best way to do this? We've got a bunch of sliders. I guess we could just reuse this, so we could have. Let's see. Let's put them in order. So we've got. Yeah. All right. So. Low boost. I10, and then we've got the attend select. Then low freak bandwidth, high freak. Oh. High freak. Okay, and then the rest of these can be deleted. But then we'll have to go here. Okay, I think we'll be all right. Where was label height? How long have you been coding for? Mike, sounds good. Thanks. In general, well, let's say professionally, since 2020. So going on 6 years. I kind of started in 2017, just kind of learning and doing it off and on. When I started, I didn't realize I was gonna actually like pursue it for work. But yeah, about 6 years, I guess. Const. Okay. What was I doing? Oh, seeing if this was gonna build. Oh, but wait, there's this weirdness right here. Well, it doesn't matter. It's not like that's gonna. Well, actually, yeah, that's gonna break because now it's gonna go out of bounds. So let's just do this. Let's just do that. That should not crash, I think. Cool. And they all painted on top of each other. Okay. All right, so how are we going to do this? There are a couple of plugins who have a vertical Pultec. Do they all do the same thing? So there's the slate one. Yeah. So the low boost and the tens going up, and then the frequency bandwidth going. So yeah, literally just shifting it. Okay. Now who else does the Audio Assault virtual mix rack thing have one? They do, and it's laid out differently. That's kind of, I don't really think that's necessarily the best. I think the configuration that Slate has it in makes the most sense. This is an actual 500 series Pultec. Pultec reproduction for rubber bands. I've never seen this. 20 to 240, 5 to 16, and yeah, okay, it kind of looks like it. Okay, yeah. This is kind of the same configuration. This looks like it's an actual hardware one. Okay, then we have this. I don't even know what this is. Okay, this one's real too. Okay. Okay. Maybe I'll do it in a little like zigzag, kind of like that, so that it doesn't look exactly like the Slate one. Well, actually, the Slate one is kind of, okay, yeah, the Slate one does that. Okay. Oh well. There's only so many ways you can lay out Pultec anyway. All right, let's see. Okay, so we should be able to do this. So we'll loop 1, 2, 3, 4. Nope. What we gotta do is y plus equals height, I think. How long you been working on this project? Probably like, I don't know, maybe, I think I might have started it 2 or 3 months ago, but I only work on it pretty much on the stream, so like that's only like 6 hours a week. So sometimes even shorter. So maybe not quite 3 months, so maybe 40 something hours, something like that. And on stream when I'm working, it's much slower than if I were working, you know, just regularly. So let's do this. Let's get rid of that. We need to set our Y to be somewhere around the bottom. So we'll actually let's do this. Let's do get height minus height. And see what that looks like. Let's see. What did I do? Oh, I gotta do minus equals. Okay, cool. Let me make sure. Okay, we're using num slider, so we'll be fine. Wait, we're using width and width. So, yeah, we don't need a height, really. Well, I guess we need it for the label. And then this can just be width. That's going to be minus width. And then we could, let's do this instead. Something like this. It can probably be kind of large. We might need to put a padding in between it as well. So let's just see what it looks like. Oh yeah, that's not enough room for the labels, so we'll have to... Well, we could put the labels on the side instead. Okay. So that's a good starting point. This probably needs to be that, and then close padding Y. Then we can set this to something, something more like this. And we will do a much smaller number. Let's try that. That's pretty close. What am I looking for? Oh, I need the Y, so that's not quite right. So I guess I'm just gonna have to... Oh, actually, maybe this will be right. It's not too shabby. Are they all in line? Well, that's gone. Yes. I'm not doing myself any favors with the in and out knobs though. Because I'm gonna want to eventually put little indications around it, and I think I don't really have enough space right now. So let's make them smaller. Like that, and then we can increase the space between them. Do something like this, maybe. Okay, 25 and 09. And then know why it isn't juice live constant. Okay, that's good. Okay, let's raise this a bit. That looks fine for now. Okay. And should we make the other dials the same size? Yeah. Yeah, okay. Okay, so now we are gonna forward to 8. And what we need to do is reset Y right here. And do that. And we need to move the X position as well. So we should be able to just do this. And we should... we could do this. Let's see what this looks like. X is width and X is get width minus width. Let's see if that's good enough. Pretty close. Why, what's up with this? I don't know. Leave that. And then we'll do, then we'll do X is equal to get width minus X minus width, maybe? If that doesn't work out, I'm just going to do it directly like this and just kind of set it. Okay, well, that's good enough to test. We just need to fill this stuff out so that, well, actually, let's do this. Let's do a Hello came in a bit late. It's more enjoyable to have the music in the background. Okay, good. Yeah. It probably gets awkward and silent without it. So I think what I'm going to do is just do vector of these, and we'll do main slider attachments. Oh wait, I already have that. Oh, okay. So what we could do so main slider attaches dot in place back std make unique, and I'm super lazy, so just gonna yoink this right here. Now we need the value tree what is it? Get tree state. And then this is going to be the annoying part, is the parameter ID. And then we can give it this. So, let's see. Is there a quick shortcut we can make? I suppose if we go look at the parameters. I mean, I would have to. Yeah, okay. I'm not going to do that. Let's just do it like this. Where are we at? Pultec EQ. So we can do something like this. Const juice string array. Sure. Or actually, let's call this IDs. Equal. Okay. So I already forgot what it's called. Pultec parameters. Low boost. Then low attend. Wow, I really wish you. Oh my god. Get out of the way. Low attend. High boost. Again, get out of the way. Low boost, low attend. High boost, high attend. Low freak. Bandwidth. High freak. Oh wait, where does the attend go? Select goes after high. I think we need to do this. Oh. Okay. Then let's see. Low boost, low attend, high boost, high attend. Low freak bandwidth, high freak. Yep, select this thing. Okay, and then we'll give it IDs I. That should take care of that. All right, let's see if it crashes. We sure did crash right here. Maybe. One, two, three, four, five, six, seven, eight. 1, 2, 3, 4, 5, 6, 7, 8. I guess we could do this just to be sure. Oh yeah, because I need to do this. Base slider. Yeah. Okay, well no, num sliders. Okay, that's strange. Assign an array and also keep a num for those and take my ID by helper function. Yeah, that would make it easy, but I guess what I could do, I've done this before, where I put an array in here and I just grab it. Sometimes depending on, I guess, well, yeah, if you fill out all the enums, I guess it's easier to get it correctly. Why is main slider's size not correct? That was strange. Okay, well, it's working. So what we'll do, we can also set the component ID. And that should work. Then what about the names? Okay, that's what all of this is. Okay, so we can get rid of all of this. Then we could okay. Okay, what's our crash? What's the actual issue? If parameter. Okay, so something's invalid. Make attachment ID. Oh, of course. We've got to, where are we at here? We got to grab our ID. So if we go back to the parametric one, for example, we need this. Yeah, just plus ID. Wait, where is ID? Okay. Wait, this is a copy. We should have it in here. Yeah, okay. So, IDs plus ID. Okay, I think that'll do it. Nice. They all seem correct. Yep. Okay, cool. Now we can do the DSP. Okay. Let's see. We'll just go to the process block. So we will do, we could just take the same, yeah, we could just take this. Num filters. Okay. Then why does it keep not, it's not automatically, editing the style. Like it's not fixing it for some reason. STD array, we're going to do the juice DSP, processor duplicator. That will be juice DSP, IIR, no, sorry, filter, what is it? Yeah, IIR, isn't it? And then juice, DSP, IR coefficients. No, what is it called? I think it's just IR coefficients. And then this will be num filters, m filters. Yeah, I did this wrong. What's the, I keep forgetting what the right one is. You see this console thing I'm working on? Yeah, it is IR and then filter. And this is DSP IR coefficients. Look. Cool. Okay, so there's our filters. We can do why is this so screwed up? Okay, 4. Filter in M filters. Filter dot prepare. We got a spec. Yep. Okay. Cool. We're gonna have some kind of update method. Update filter. We'll take in, I guess, let's do this using filter is equal to can I do it like that? Okay, there we go. So then we could take in, I guess, a reference to a filter. And then const float gain cutoff in Q, I guess. Actually, maybe it would be easier if we just do update all filters and just take in that. Because like in here, we'll have, for example, const auto low boost is equal to parameters dot low boost get yeah, okay. Yeah, okay. We didn't do the attends, so that's gonna be annoying. One, two, three, four, five, six, seven. I'm missing one. Low boost, high boost, low freak, high freak, low attend, high attend bandwidth. And then is there a, oh yeah, the select. Okay, that's cool. Oh, no, we are going to have to do it like that. So, okay, let me just write this out and then look at it after and see if it works or not. So I guess we'll just do M filters, K low boost dot state. So gotta do that. Oh, is equal to that, and then juice DSP IR coefficients load, and this is going to be make low shelf, and this is going to be, oh, we need the sample rate. We're not going to oversample this, so we should be able to just do this. Or not const, just float. Do that, and then we'll take sample rate up here. Sample rate, and then this makes a little bit more sense. That works. Okay, then we can take sample rate, stick it in there, and then we can do, okay, low shelf. So cutoff is going to be low freak. I wonder if it's okay to update the filters in here. Cutoff is low freak. Then bandwidth. Okay. I guess that'll work. Because in another project, I have an update method like that, and I'm just calling the update method in the update parameters method, so this really shouldn't be any different. So All right. Okay, low 10. Okay. Then we've got low freak also, and then low 10. Okay. And then we should be able to copy these two. So let's do that. Oh, well, I don't want to do that. Okay. We'll take this one. Okay, that should be good. I might be doing this wrong. So the attend is a complete another filter. Okay. The attend select, I mean. So let's do, I know it says it's a shelf, but it'll be easier to do this with a low pass and see how it works. So this will be a low pass, which you give it just sample rate and frequency, which is going to be the attend select. I have no idea how it chooses how to do this. Is that everything? The low boost filter, the low attend, the high boost filter, the high attend filter, then the high attend select, which is like a low pass kind of. So that one should be set to 20,000 instead of the default. Where's it at? Select, yeah, 20. Okay. Oh, also what we have to do is for the attends, we have to actually pass in negative. Oh, and also this is a low shelf. So low shelf, this should be high shelf, low pass. Okay. Okay, we don't need this because we're going to be calling update parameters before the block. So I think we can go ahead and do this. Filter, yeah, in filters, and then we'll do filter that process, but this is going to be juice DSP process context replacing float. Give it the block, not the upsampled block. This might be ready to go. Let's do a standalone build real quick just to make sure it doesn't crash. Okay. Oh, we got something wrong. Okay, doing something wrong. Let's see, we prepared them. 1, 2, 3, 4. Oh, yeah. So these aren't filters. Yeah. Okay. Whoop. I don't even know. There's only 4 filters. No, there's 5 filters. Low boost, low 10, high boost, high 10 select. Okay. And then 5. Okay. That should be what the issue was. Let's try it. Okay, here we go. We got something here. All right, let's see. Low boost. That looks like a low boost. And then a low 10. The only problem is the attenuate's probably gonna have to be in a different spot because of that whole Pultec low end trick. So let's leave that for now. And then here's the boost for the highs. So let's move the frequency. Okay. Bandwidth. Okay. That actually might be what we want to use as the bottom. And then maybe something like that for the top. Cross that bridge when we come to it. So I think we need to figure this out because the whole idea with the Pultec is that with the even with the high tints at 20, it's not a low pass, so it's not lopping off, you know, at the Nyquist. You're getting a little bit of stuff above it. So we'll look into that. Now, does it say anything in the data sheet about the relationship between the two low? No, I mean, it says they're at the same frequencies. But I mean, I would think that we would do something like maybe the frequency times 2. Well, actually, we can do a juice life constant. Let's do that. Okay, low boost here, low with 10 there. Let's put them both, I guess, in the middle. Okay, I'll move that around a little bit. That's looking more like what you're supposed to get, except it's too much. And the top end is still, the top end should be a little bit above, I think. So what if they're at, so it seems to work if their values are, if the attenuation is about half. Well, actually, let's see, that's at let's see, this is 6. This is 3. So actually maybe around 4.5 looks good. So what about these values? Something like that looks good. Let's go with that. That's about 1.44. Now, what's the relationship here? Wait. 4.5 divided by 6. 7.5. Okay, so maybe we could do that. Let's see. So this was about 1.45-ish. Okay, or not. Oh, yeah. And then I think what we'll do is the gain for the attenuation times, it was about 0.75. Okay, so now if I boost it about halfway and then attenuate it halfway, no, it's still, wait, why am I getting the same result if I have that multiplier on it? Did I make a mistake in my logic? Let's try at 0.5. Let's just see what happens. Okay, halfway. So let's say 6, and let's do 3. Or 6, actually. That seems good right there. So what if I go all the way? Yeah, okay, that seems to work. Okay, might be good there. I think the funny thing is, in the data sheet, it says, where is it? Do not attempt to boost and attenuate simultaneously on the low frequencies, and it's what everybody does. So maybe this original, like this is really old. So maybe their original units, so I guess maybe you could damage it in some kind of way. I don't know why it says don't do it. Let's see. Oh yeah, let's look at these. Let me download this so I can rotate it. We don't really have to try to match this perfectly, but get a sense of the cue, I guess. Where's this peak boost come from? Is the high shelf actually supposed to be a peak? And I completely missed it. Well, good thing that's an easy fix. Well, actually, let's read and make sure. Where'd it go? Oh yeah, it does say peak boost. And then the attenuate is a shelf. Okay. All right. High boost, make peak filter. I think everything's in the same order. Yeah, okay. Let's try that out. Okay, low boost. Okay, so I think I need to ease up on the bandwidth. Okay. Well, it's pretty good right there. So is that 16? So if we raise this a bit, and then if we let's go all the way up to like 16, or it goes up to 13-ish. How does that look? Good enough for now. And then if we go all the way up to 100, so not quite matching up there. It needs to go about 200 for some reason. Probably because of the queue. Yeah, it looks like it's about halfway of where it needs to be. If I go to 20, yeah, it doesn't seem like it's at 20. So the low boost, low frequency. Okay, that seems like it's actually at 20. And now it looks like it's going all the way up to, well, not quite, but let's do this. And then let's traverse here. Yeah. Okay, close. That's good enough for now, I think. Do we still look okay on the, no, we sure don't. Let's see, that kind of ruined our, oh, well, no, we're good. I forgot. They need to match exactly, not just halfway. And then if you raise the bandwidth, you get a much more pronounced effect. So let's change the Q from Let's see, let's do 0.4 to 0.8. Seems to work well for this filter. And then what about the high? Yeah, it seems to work for the high as well, so that's good. Okay, so we'll go 0.4, 0.8. Okay, that works out. And let's do about 0.5 by default, or let's just do 0.4. Okay, cool. Let's make sure nothing weird happens. Yeah, that bandwidth seems to be fine. Lastly, let's do the attend select. Where's that data sheet at? So peak boost, shelf attenuate, not a low pass, but if this is a shelf attenuate, I feel like I'd have to set the gain to be like negative 100 or something. Okay, let's see. Where are we at? High attend select. This is gonna be a high shelf. Sample rate. High attend select for the frequency. We should probably set the bandwidth. Let's see, what does it look like in here? Pretty smooth. Maybe 6. And then I don't know. High shelf. So it's over there in high attend select. Okay, I guess let's just try it out and see what happens. That negative 100 might be way too much. Yeah. And that's at 20 as well. So, what if we just do something normal like 20? I can select, make high shelf. That sure looks like a low pass. Did I accidentally hit undo or something? No, it says make high shelf. This is kind of strange. So if I high boost, and then I attenuate, that doesn't look like 5. That looks like 1,000. I guess it could be the Q. Let me just, I don't know why I keep doing this, but let me just do a live constant here. And what was that? 0.4, whatever. Constant. I suppose while I'm here, I could do this. Let's start with it all the way down. It says it goes down to like -16, which is kind of crazy. Because if I go all the way down there, it's gonna... This is better. It's not perfect. Okay. And then if I go all the way back up, yeah, okay. But yeah. The thing is, it's not nearly, on the hardware, it's not nearly as sharp at the top right there. Messed it up. Let's also see if we can find a cutoff position for 20,000 that makes sense and works for everything else. Okay, so this is 20K. We gotta go back down to -16-ish. Okay, this... Oh, I messed it up. So this is 20,000. What if I go up to like 40? Oh, it just breaks. Okay. too much. What frequency does it let me go up to before it breaks? Is this plugin doctor automatically doing this kind of low passing? Or is it the juice filter that's doing it? I don't know. I'm gonna mess with it some more. Study these graphs a little bit more. Let me undo that. I think it was working well enough at 0.4. And then this needs to be negative 16-ish. Okay, cool. We'll leave it like that. I'll mess with it some more. Try to fine tune it. I'm not really going for a one-to-one exact perfect replica, but you know, just have it match at least a little bit for it to be a usable Pultec. All right, so add Pultec editor and DSP. All right, cool. That'll do it for me tonight. Thanks for hanging out. Be back Friday, same time.